Oh, there's the last ding. Everybody's here. Okay. That checks out. That checks out. All right. Well, sounds like a good place to stop and start class. Good morning, everybody. I hope you enjoyed your weekend. Anyone get out and play in the snow? Anyone like build snowmen, make a snow fort? It's really good snow for making forts. There. I was really tempted to like just call off class and be like, no, I'm gonna go make a snow fort, guys. You're on your own. Maybe next time, maybe next time. All right, but if we hurry and finish real quick, we can get out there and we can make snow forts. So, let's go. Today, last week, let me start there. Last week, right, we finished chapter 8 with the conic sections, thank goodness. Those are probably some of the most confusing section. Actually, everybody did pretty well on the test. So congratulations, guys. You are kicking butt, despite all of everything. So now we are going to begin one of my favorite topics, rational functions, right? Or at least the chapter now, right? Chapter 9 is rational functions. And this has some really cool stuff going on. One of my favorites, absolutely. But we got to start with the basics, okay? Multiplying and dividing rational expressions. Before we get to the functions, let's make sure we can deal with the interactions of and the simplification of the expressions, and then we'll start graphing them, okay? So first of all, what the heck are we talking about? What is a rational expression? Okay? It's not like a phrase that sounds logical, okay? This rational comes from ratio. Let me zoom in. There we go. Okay? Rational meaning a rational number, right? Can be written as a ratio, okay? Which, of course, you remember, compares two quantities. One on top of the other in the form A over B, right? If you can't do that, you can't write the number as a fraction. It's an irrational number, like the square root of 2, okay? So now we're dealing with not just rational numbers, which is most of the time, but rational expressions. So we're taking all that algebra stuff, plus x minus x squared, right? And we're going to write two of those things, one divided by the other. Like this, right? Here's a perfect example. You've got up top here, a plus b is an expression, an algebraic expression. We can put anything we want up here. For right now, for most of this chapter, I think entirely this chapter actually, we're going to stick with ratios of polynomial expressions. Okay, so it'll be a polynomial up top divided by a polynomial in the bottom. Let me write that down, right? Okay. Most times a ratio of polynomials. But we could do other things. We could have, the sine of x divided by 3 to the x, right? And you could throw, trig and exponentials or logs or, other types of functions, operations, expressions. You could put all of that in there. But most of the time, and certainly within this chapter, we will be dealing with polynomials on top of the bottom, which is great because we already know how to deal with polynomials, right? Don't worry about the conic sections bit. Okay? Those are actually not going to come back until the final. We won't need those for a while. We're going back to polynomials here. But now it's twice as good. It's one polynomial on top of another. How are we going to simplify this? Do not start crossing out A's and B's. Don't do this. Oh gosh, please don't. No. Okay. Yes. Oh, same thing on the top and bottom. When you have the same thing on the top and the bottom, you can reduce, cross those out, do that. We do not have the same thing. Okay. This is being added. These are being subtracted together. These are not the same thing. I can't just separate these and treat them as such. Okay. They have to be separate, such as the division. If this was 2 times a plus b and 2 times a squared minus b squared, oh, then I could reduce the 2's on the top and the bottom. Okay? They have to be multiplied by the numerator and multiplied by the denominator. So factoring here is going to be critical. We got to find common factors. A is not a factor of a plus b. Okay? When in doubt, factor it out. Factor the numerator. A plus b is as simple as it gets, right? I don't have anything being multiplied there, so you're not going to factor anything out. So it's just a plus b. But down here I have a squared. A squared means a times a. Something is being multiplied. In fact, does anyone recognize what type of special thing this is? It's not just any binomial. Think back to your special products. Which one is this? What's the, when you have a subtraction, it is called a, not a sum, but a, and both things are squared, so that makes it a
difference of squares, maybe?
Difference of squares, very good, you've got it. Difference of squares. Which means it factors into square root of one, square root of the other, sum and difference of the two. So one version is a plus b, one version is a minus b. Which means our version, now this is a plus b up top over a plus b times a minus b. Now, a plus b is being multiplied by the rest of it. A plus b is a factor. So when I see, hey, a plus b and a plus b, the whole thing, that is reducible. Remember, everything is always multiplied by an invisible 1. So I don't get nothing up top, I get 1. So the answer is 1 over a minus b. Questions how we did that? Okay, that's simplifying. We want to start multiplying and dividing these things. So, more stuff is involved, but it's still the same rules. If I said multiply, 2 times 3 times 6 out of 7, you would do the same thing. You'd say, multiplying fractions is easy. I multiply all the numerators across. 2 times 6 is 12. I multiply all the denominators across. 3 times 7 is 21. And now I simplify this fraction. Let's say this is reducible by 3, so we get down to 4, or by 3 is 7. There we go, right? And you reduce your fraction. Same thing. Same thing, except some of you may have noticed, actually before I erase that, hey, wait a minute, I could have reduced this first. We could have gone, hey, 6 is divisible by 3 already. That's 2. That's 1. Yeah, save yourself a headache. Reduce first, multiply later. Okay? Reduce first whenever possible. Make your life easier from the get-go. So let's see. Are there anything I can reduce within the fraction? So this numerator with its own denominator, does anything reduce? No. This numerator with its own denominator? No. But rather than rewrite this thing first, multiplying and then reducing, let's check. Let's just go, this is one big fraction with all this multiplied by all that multiplied by all this. Everything is fair game. I can crisscross reduce. Anything on any of the top reduces with anything on the bottom. So look at this. 2 reduces with 8. Now that's not a 6, huh? 4. Right? Does 3 reduce with 5 or 4? No. Okay. So we're left with a 3. It's fine. Oh, I see a squared and a squared. Look at that. Exact same thing. I see one instance of b. This is b squared, so I only cross out the squared. I still am left with a b on the bottom. Your exponent rules, right? b divided by b squared. This is b to the 1. 1 minus 2 is negative 1. b to the negative 1 is 1 over b. About c's. Any c's reduced? There's 1 down here. There's squared, so there's 2 up there. We get rid of the square. We're just left with regular c. What's left? Read across the numerator. Nothing, nothing. 3c. Denominator, 5, b, and 4. 5 times 4 is 20. b. Okay. Final answer. That's not so bad. Multiplying fractions is pretty easy. All right. Hot shot. How about dividing fractions? What are we going to do with this guy? Who can tell me? Don't give me the answer. Give me some words here. Name some things we are going to have to do. I'll give you a hint. One of them starts with F. And one of them starts with M the R. Oh, Nathan's got it. Reciprocal. Yeah, what are we going to do with the reciprocal? Reciprocal? I don't remember how it's spelled. I'm terrible at spelling. That's why I teach math. Reciprocal. Yes, okay. Got it right the first time. What do we do with the reciprocal? Multiply. Multiply by the reciprocal. Okay. And looking at this, what do you notice about these polynomials? This isn't as simple as it was before. This has got multiple terms. We got a squared up here. It's a full-on quadratic. Hey, I bet we could F-word factor. He's got it there. Factor that, and hopefully something will simplify, right? I'm hoping something is going to simplify there. Okay, multiplied by the reciprocal. So, you have two options. Either you can rewrite this and take this second one and actually flip it. Rewrite this up top and this on the bottom, and that will help you visualize, okay, this crosses with that, and you'll be much more consistent. Or if you want to really try, you can try to conceive of like, okay, this is not what's actually being reduced here, but like, okay, this is going to cross off with the numerator on this side, and then like this one with the denominator on this, right? But this denominator with that numerator. And so you can keep track of the fact that all of these are flipped as you're crossing things off. You can try to do that and save yourself a little bit of writing. For the sake of clarity in this video, I'm not going to do that. Okay? We are going to, I am, however, going to copy that one directly, and let's make it blue. No, why would we do that? You know what? We still got to factor. Forget that. Factor it all first. Then we'll worry about rewriting stuff in the first place. Okay? Can we factor this top one? Is there anything we can factor out of that? Actually, yeah, right immediately I can see everything is a factor of 6. So we get 2p squared plus p minus 1. Can we factor that? Take a look at it. Here's a hot tip, right? When you're in this kind of situation, ask yourself, hey, is there any way that the book is maybe being helpful here? And could it possibly be the case that my factors up here are going to appear somewhere so that they actually reduce? So look around. Check, hey, could p plus 1 be a factor? Could p minus 3 be a factor? Or 2p plus 10 be a factor? Or maybe these aren't the final factored form. Maybe I should factor something else first. Let's factor other things first. But we'll come back to that one. Because 6p minus 3, I can factor out a 3 from that. And we get 2p minus 1. 2 and 10 are both even. Okay, so factor that. That's going to be, factor the 2 out, you get p plus 5. Okay, so that's entirely factored, that's entirely factored. This is entirely replaced. This is 4 times p plus 1 squared, that's all multiplied. So there's no, that's fully factored. But now I've got some better options to look at. Hey, do you think 2p minus 1 or p plus 5 might appear in here? This started with a 2. One of them has to start with a 2. Let's try it. Let's think about this. 2p minus 1 times p, and I've got to end up with minus 1 there, so this has to be times plus 1, right? So I get plus 1 times minus 1, and then 1 times 2p is positive 2p. Negative 1 times p is negative 1p, so 2p minus 1p is net 1p. This works. Hey, sneaky, sneaky, right? Oh, and p plus 1 was one of the factors down here. Hey, there you go, right? So factoring, and you can use your, the standard factoring tricks, or you could look at like, what if this problem was actually easier? Could that work? And like try it? So I think sometimes it's easier to check and multiply these out in your head than try to factor it in your head without writing additional things down. So there you go, little tip there. And now I'm going to rewrite. Now let's do the rewrite. So now we have 6 times 2p minus 1 times p plus 1 divided by 4 times p plus 1 squared times the reciprocal, flip this, 2 times p plus 5 up top, 3 times 2p minus 1 on the bottom. Now let's cross tops with bottoms. This is on top, this is on the bottom. This is on top, there's another one on the bottom. P plus 5 doesn't appear anywhere else. But 6 is even, 4 is even, so that's 3, and that's 2. And ooh, look, 2 and 2, and 3 and 3. Oh, yes, it's a cross-out spree. What's left? Who has survived this massacre? P plus 5 is the only survivor in the numerator. And I'm crossing out the numbers. Secretly it's a 1 that's left over. Ignore that. There's a p plus 1 left over, right? We only crossed out the squared part because there were technically 2 of these being multiplied. So one of them is left. So we got that guy. That's our final answer. Whew. Okay, not bad, but the division part is just, flip and multiply. The complicated part was now we had a full-on quadratic that we had to factor out. Not too bad, right? Okay, one more example. Simplify this thing. Like, holy cow, what the heck is that? All right. What is that? How would you describe that? That thing. What is the topmost structural element? I don't mean top as in the top compared to the bottom. I mean greatest order, biggest picture, right? If you zoom way out, actually, yeah, zoom way out until it's teeny tiny, you can barely tell. It is a single what? It's one fraction. Okay? This is one fraction. Within this one fraction, the numerator is a fraction and the denominator is a fraction. Can everyone see that? Okay? If it helps, let's make this middle division bar extra thick. This is one of those unwritten skills in math. The ability to look at this thing and tell what it is. It's one big fraction. It's a fraction of fractions. Okay? Treat it as such. Okay? Also, treat it as, hey, wait a minute. This means divide. This means I'm just going to take this fraction divided by that fraction. It's a division of rationals. Oh, we just did that. The secret was multiplied by the reciprocal. Okay, but you have to notice where the cutoffs are, okay? Because the division bar is not always going to be bigger and thicker and bolder for you, okay? You might have, it's like it's just a stack of numbers, right? There's nothing to differentiate one level of fraction over the other, but it is. They're nested inside each other. So think of this instead as, I'm going to go back to blue, right? C cubed d cubed over a times reciprocal. Bring the bottom of the bottom to the top, and the top of the bottom in the bottom. Okay? So now, what reduces? I've got C and C. Well, there's two of them here. The smallest power loses. Biggest power remains. We just get one C, right? 3 minus 2 is 1 left over. D has only 1 on the bottom, so we'll get rid of 1 from the top. So there's 2 left up top. One single power of A and A. Power of X gets rid of a single power of X there, so we're down to 1X, 1C. So we've got C, D squared, X to the, and oh, I crossed everything off the bottom. There's nothing, that's it. Let's put it in alphabetical order, which it is, C, D, then X. There we go. Done. All right. Not that terrible, right? Of course, we could have a factor thing inside of here. We could have had a quadratic, and you've got to factor them out first as well. But that structure overall, just another way to show division of two rationals. Okay, any questions there? No? All right, then we've got like 22 extra minutes here in class. Go ahead and start on your worksheet for today. And let me know if you have any questions there, run into any issues. I'll be on standby. You guys get to work.